Good morning. Today's my lecture topic is nuclear power plant. In nuclear power plant, first one is the construction. Construction of a nuclear power plant includes nuclear reactor, pressure vessel, control rods, fuel rods. These are the construction devices. In nuclear reactor, the core part of the power plant where nuclear fission occurs to generate heat. A strong containment vessel that holds the reactor core and ensures safety under high pressure. Control rods inserted into the reactor to absorb neutrons and control the rate of the nuclear reaction. Fuel rods, these are tubes containing uranium or plutonium pellets which undergo a fission to produce heat. Moderator in a nuclear power plant, a material like water or graphite used to slow down neutrons, facilitating the fission process. In cooling system, a system that transfers the heat generated in the reactor to the steam generator. In steam generator converts the heat from the reactor into the steam to drive the turbines. A turbine, a rotating machine driven by steam to convert thermal energy into mechanical energy. A generator converts mechanical energy from the turbine into electrical energy. Containment building, a reinforced concrete structure that houses the reactor and serves as a safety barrier to prevent radiation leaks. Cooling tower releases waste heat into the atmosphere, often seen in nuclear power plants as tall and open structures. Emergency coal building and a spent fuel pool, a pool of water used to cool spent nuclear fuel after it has been removed from the reactor. Turbine generator hall, the section of the plant that contains the turbine and generator where mechanical energy is converted into electrical energy. A transformer is a device used to step up or step down the voltage electricity for transmission to the grid. Reactor pressure vessel, a thick-walled high-strength container that holds the reactor's nuclear fuel and coolant. The primary containment of the reactor vessel and all its immediate components that prevent the escape of radiation into the environment. Working principle of a nuclear power plant. The working principle of nuclear power plant includes nuclear fission. At the reactor core, uranium or plutonium nucleus undergo fission when hit by neutrons, releasing large amounts of energy. Next one is heat generation. The fission of uranium or plutonium atoms generates significant heat which is absorbed by the coolant. The coolant circulation. The coolant circulates through the reactor core, absorbs heat and carrying it into the steam generator. Steam production. The heat from the coolant is transferred to water in the steam generator, turning the water into steam. Turbine rotation. High pressure steam flows into the turbine, causing it to spin, convert thermal energy into mechanical energy. Electricity generation. The mechanical energy from the turbine drives the generator which converts it into electrical energy. Heat dissipation. The steam is condensed back into water in the condenser and the process continues in a closed loop system. Continuous monitoring. Sensors and control systems constantly monitor radiation, temperature and pressure to ensure the reactor is functioning safely. Next one is parts of a nuclear power plant. Nuclear power plant consists of reactor core, fuel rods, control rods and moderator, primary coolant and steam generator. These are the parts of the nuclear reactor. The turbine, a rotating machine that converts thermal energy from steam into mechanical energy. Condenser, a device that condenses the steam back into water after it passes through the turbine. Containment vessel is a reinforced structure that encloses the reactor to prevent the release of radioactive materials. Radiation shielding. Materials like concrete or lead that shield work from harmful radiation. Emergency shutdown system in an automatic system that quickly shuts down the reactor in case of an emergency to prevent overheating. Reactor pressure vessel holds the reactor's core and coolant under high pressure during operation. Next one is applications of nuclear power plants. Electricity generation. The primary application of nuclear power plants is to produce electricity for domestic and industrial use. Medical isotopes. Nuclear reactors can be used to produce medical isotopes for cancer treatment, diagnostics, and other medical purposes.